The x86 architecture offers two flavors of rotate instructions. One is an ordinary rotate instruction and the other is rotate with carry instruction. In this video, we will look at the ordinary rotate instruction and see some examples of left rotate and right rotate using the ROL and ROR mnemonic. In general, the operation of the rotate instruction is very similar to the shift instruction, except that in the case of a shift instruction, the bits that are being shifted out are lost, whereas in the case of a rotate instruction, those bits are pushed to the other end of the register. Here is an example of a rotate left instruction. The data which is loaded in the EAX register is hexadecimal dead beef, and this is the binary representation of the data. The instruction that is used is rotate left EAX, and the immediate operand has a value of 1. The immediate operand specifies that in this case the rotate operation on EAX be performed exactly once. So as part of the execution of this instruction, the CPU will shift left the contents of the EAX register by 1. The most significant bit that is shifted out will be copied to the carry flag, and since the entire content of EAX is getting shifted left, there will be a vacant position in bit 0. So the bit that is shifted out, in addition to being copied in carry flag, will also get copied to the vacant bit in bit position 0. So after the rotate is done, the register content will look something like this. The carry flag will have a value of 1 since the most significant bit was a 1 and it got copied into the carry flag. The EAX register has been shifted left by 1 and bit 0 was vacant and the most significant bit got copied to bit position 0. So the result in the register is hexadecimal BD5 B7 DDF. The rotate right instruction is very similar to the rotate left, except that in this case the direction of the shift is right. So here the least significant bit is the one that is going to be shifted out and it gets copied to the carry flag and it makes its way all the way to the most significant bit where there is a vacant position introduced because of the shift right. So after the rotate right instruction completes, we have a result of EF56DF77 in hexadecimal in the EAX register, and the carry flag is a 1. Now let's head over to the IDE and let's see the rotate instruction in action. Here I've already filled out the output and the input list. The input variable is dead beef and I have mapped it to the EAX register. After the rotate completes, the output is also going to reside in the EAX register. So I use a specifier, the constraint of A for the output as well, and I map it to the output variable. So let's start with the rotate left instruction. So I use the rotate L instruction and I specify an additional L to the assembler for the 32-bit flavor of the instruction. The immediate operand is 1 since I want the rotate count to be 1 and I want the rotation to be performed on the EAX register. So let's run this and we get a value of BD5 B7 DDF, which was the value that we saw on the slide. Now let me quickly replace the rotate left with rotate right and check the value, and again the value seems to match what we had on the slide. The last thing that I want to show you is another flavor of this rotate instruction. Here we are using the immediate format, and there is a format where you can specify the count in the CL register. So here what I want to do is use a count of 16. So when I do a rotation of 16 times on the input, I start off with dead beef and I will wind up with beef dead. So let's see if this works as per our expectations. So here I need to do one additional thing to the input list. Since my rotate count is going to reside in the ECX register, I specify the constraint C and I map our variable num to it. So ECX is going to have the number 16, and the rotate right instruction is going to use the immediate the count value in CL register, and it's going to rotate the value in the EAX register by the count specified in CL. So let's run this and see if the output is beef dead. And as we expect, the output after rotation is indeed beef dead. So I hope this video gives you an overview of the rotate right and rotate left instructions and how it's different from the shift right and shift left instructions. In the next video, I will talk about the rotate with carry type of instructions.